Good morning, everyone. So my name is Joe Monti, and I am a senior software engineer at VidMob. You may have heard of us. Hopefully you'll hear some more. I've been a software engineer for about 15 years. I work on a lot of backend software, front-end software, everything in between, a lot of data. Recently, a lot of performance analytics and image recognition and all kinds of stuff in between. So today I'm going to be talking to you about where to start when starting a project. Before I get into that, just a little bit more about VidMob and what we're about. We're a platform that provides sophisticated workflow tools that help simplify the video creation and collaboration process, allowing marketers to turn their various forms of video, image, and other assets into awesome videos that run on social platforms, Facebook, Snapchat, etc. And we provide the technology platform that allows that collaboration to happen. So first, before we get into anything further, I wanted to just define what I meant by project in the context of this talk. And by project, I meant a web or mobile application. That application will have users, hopefully a lot of them, and you'll probably need to build it fast. I apologize, it's a little hard to read, but that's essentially a very basic architecture overview of what you've got at the top, web or mobile application that your clients are interacting with. You'll have some sort of API that the web or mobile application is communicating with to store data about users, things that are happening on your platform. There will be some sort of database and probably external services that your platform will need to communicate with to power what your app does. And kind of the first part in the process is defining and answering some questions that are important to what will go into the technological decisions as well as other aspects of how you're building your application. What are you trying to achieve? What is the goal of your project is an important one to start with. Write down what you think kind of objectifies the mission of your product and use that to drive the remainder of what you're working on, and because it'll be important for you to focus on what's most important to your application. And what is your audience? What does your audience look like? What are you trying to target? Are you looking to target developers, small business owners, college students? All of these things could go into determining what your areas of focus are and how you approach building your application. Things that are important about your audience are, of course, the audience size. Are you targeting a relatively small set of users initially? Do you expect that to grow over time, or you do kind of expect that to maintain? Or from the bat, do you want to be able to scale infinitely? And there's some amazing ways that you can build your application to kind of grow it very quickly. Another thing that's important about your audience is the stickiness, which means how often are they coming back? Do you have a lot of users that come and go, they don't really stay around too often? Or are there a relatively smaller set of users that are interacting very heavily and very frequently with your application? And then other parts that come into play are the technical literacy and device compatibility of what you're trying to do. Are you focusing on only modern browsers, modern smartphones, or do you have a much broader audience where you need to do much more device and browser testing? And those things can help drive what you ultimately build into your product. Then on to the developers and other resources that are going to go into building this thing. How big is your development team? Is it just you or a handful of people? How are you going to split up your work? Other important roles that go into building this are definitely things like design and user interface, testers to make sure things are working, and marketing and sales to make sure that what you're building gets out to the people that you're trying to get it to. And those things may initially just be you, or you may be working with a team that has, some specialty in design, some specialty in marketing, just trying to organize your team and split up the work to get things done. How much time do you have? Time is a lie, you have none. The best thing you could do right now is to get your product into the hands of users as quickly as possible. And you don't really have the leisure of taking your time and making it perfect. You want to get something out quickly. And to do that, you want to focus on defining your MVP, or minimum viable product. And there's going to be a great talk later today. James Kupernick is going to be giving that on managing your MVP, and not just the MVP of what your initial product is, but as you build out features and functionality, focusing on the core purpose of that into something that you can iterate on quickly. Onto planning your architecture. Let's break it down. Any Overwatch fans? So on the front end, you'll typically have a web application. You might have a mobile application. You might have both. And there are certain technologies that kind of work well across all of them, or you might want to focus on the particular technology to build that. On your back end, you'll probably have an API that your web front end or your mobile front end will be talking to. That API may be composed of many services using a microservice architecture, trying to separate out the functionality and the work into smaller, more manageable components. Or you may not really have an API. No API, no problem. I don't know. It depends on your situation. There would be good ways of skipping an API if it's not really that important to what you're doing. You just need to maybe get a mobile app up and quickly, prototype maybe. There you can use API services that can let you store some data, interact with some databases in a kind of a high-level way. Firebase is a great service to do that with. Some bad ways of skipping an API, I would say, are baking your API into your front-end web app. That can be really easy to do, but I would highly discourage it. Do not put your API into your front-end web app. There's a ton of reasons why you would want to do that. It allows you to more independently scale and deploy your application front end from your API backends. And because each of those things will have very different characteristics about how they operate and how you scale them as people are using them. On the web side, the requests are going to be fairly short, just pulling in some JavaScript, HTML pages to your web front ends. And your API services may take more time to process requests, interacting with a database, may have much different memory and CPU requirements for how you actually allocate and scale those resources once you get it out into a significant amount of users. It also makes it much easier to develop your front-end web application if your front-end developers don't have to have a database installed, have their API running, install all of the packages for the API. All they have to do is maybe if they're building an app that's running on Node.js, and just do an npm install and run, and the front-end developers can be up and running. You just point at the right API. In terms of how you actually develop these things and build it, you'll probably have a separate Git repositories for your web front end from your API backends, and you may even use different languages and frameworks in order to develop them. The key here is using the right tool for the right job. Which there's a lot of differences in how various programming languages and web frameworks and various other frameworks operate that work better for different situations. And I'll go into some of those later on. Onto languages and frameworks. So recently, Bunk, which is an analyst firm that focuses on developer communities, released programming language rankings. Looking at the GitHub and Stack Overflow data on basically trying to measure the effective community size and activity. And I've highlighted a few languages here: JavaScript, Python, and Scala. If I had 3 languages that I could use for the, right now, and that's all I could use, I would definitely choose those 3. They span a wide range of capabilities and functionality that really could almost let you do anything. JavaScript on the front end, Scala for backends, APIs, databases, and Python for doing all kinds of data and scripting stuff. In terms of what works well on the front end for the web side, of course, you have JavaScript. That's what runs in your browser. But there are extensions to that, which makes working with JavaScript much easier, especially in the context of certain web frameworks. For instance, the Angular web framework works really well with TypeScript. TypeScript is basically an extension of JavaScript, which adds static typing. And then JSX, if you're working in React, that's usually what you want to use. On the Android side, the core language for developing Android applications would be Java. However, they recently extended support for a language called Kotlin, which is a language that compiles into the same bytecode that Java does on the JVM. However, it's much more modern programming language, allowing you to have to write much less boilerplate, and there's a lot of functionality. It takes a lot of inspiration from Scala, which is a functional object-oriented language, which is really awesome, but Kotlin works as well. And then, of course, you could kind of build Android apps with JavaScript, although there's some caveats there. I'll get into a little bit later when I talk about web frameworks or frameworks for Android. On iOS side, Objective-C is the core language there, but you can also use Swift, which is another more modern, more easy to program in language, more easy to learn. And if you were starting an iOS app, I would definitely go for learning Swift over Objective-C if you had the option. And of course, you could also develop iOS with JavaScript, but again, there's a similar situation to Android. On the backend side, for building APIs and core services, there's a much longer list of what you could start getting into. And these are maybe some of the top options you would have. Java, of course, is the reigning champion for quite a while, but there's some cool extensions or technologies built on Java, Scala, and Groovy, which are I find much more fun to use. I prefer Scala, but Groovy is awesome as well. Groovy is more like a scripting language. Scala is more, has an awesome type system, which you can do really fancy stuff in. Python is really great in the backend as well. It's really easy to learn, fairly simple language, but very powerful, and some awesome tools to let you program that on the back end. JavaScript, if you want to stay in the JavaScript world on the front end and your back end, you could, of course, use that running in Node.js. You can write APIs in it. You can do all kinds of back end stuff as well. Then Ruby, Golang, and the list could go on and on from there. So onto frameworks, and these aren't necessarily frameworks in the general term. They're more core technologies around which you would build your application. They're kind of like libraries. Angular is more like a framework. So React is a web framework or library, and it really helps you build awesome web applications that are super fast, super easy to build and iterate and manipulate and code against. And I really like working in React. That's my favorite of the bunch. Angular is another very powerful web framework, which is more like a fully featured web framework. And it has some issues. It's a little slower than React, especially for larger applications. And the community has been a little volatile lately. There's been like a huge breaking changes recently, but I think they're kind of getting through it. Anyways, then jQuery is a fairly old library that's been around for quite a while that have been used fairly heavily. But I would say today, the browser support, the web frameworks kind of make jQuery much less relevant in today's ecosystem. So I wouldn't recommend learning it, but I'm sure you've come across it in your travels if you're doing any front-end work. On the mobile side for frameworks, there's, of course, the native environment, IDEs, the languages for that mobile platform building specifically for it. But then you could get into building hybrid web applications. And I say web in quotes because they're not necessarily building directly with web, like React Native, for instance, is using the languages of the web, but building it into an actual native application that runs on cross-platform, iOS, Android. Cordova is another example, which is more like a web wrapper around your application. But if you want to have a singular code base that can work and that you can share things across the web, iOS, Android, React Native, and React ecosystem in general, is a great way to go there. If you want it. Yeah, absolutely.
Okay. What's your experience in that level of effort in going from, let's say you started with web React, and going from React without really much consideration for mobile necessarily, and going from that to React Native in an effort to support mobile?
Yeah, the biggest difference is all of the views will have to change because you have to code specifically for the. Yeah, well, depending on how you're splitting out your application, you can make your actual views very lightweight. So all you do is pass them some data that other components are gathering from APIs and stuff. So, depending on how you're split out your application, it could be a large portion of it. It could be a smaller portion of it. But maybe that's a good time to start refactoring things. And
yeah, I guess sort of you have to look at Redux too.
Yeah.
And sort of assessing that effort, I guess.
Yeah, so there's React has a number of, well, I guess recommend or commonly used tools, Redux being one of them. But one thing I like about React is you can kind of plug different things into it that kind of like work for what you're trying to do. Any other questions? So on the backend side of frameworks, each language has one, maybe several frameworks that work well for that language. I've identified some popular, I guess the standard ones for each language, which you might be using on the back end. Java uses the Spring framework, or I guess Spring framework is, I guess, the biggest framework for Java. Spring framework is a gigantic project with tons of components for almost anything you would need to do on the back end. And it's very powerful. One of the things that these frameworks do for you on the back end is, I guess, the primary thing being that it helps translate the requests, HTTP requests that your backend servers are getting, and translating them into executing actual code. But then a lot of frameworks go beyond that in supporting being able to translate, interact with databases, maybe mapping tables to objects, or maybe providing some query interface. And then there's a number of other things that these frameworks can do, like caching and things that are very helpful for building and scaling a backend application. For Scala, there's the Play framework, which is, Play framework actually works for Java as well, but the Scala version of the Play framework fits very well in the Scala ecosystem, allowing you to build very high performance, scalable backends. I like Scala. So, and then for the Groovy side, there's Rails, which is based on Ruby Rails. And then for Python, there's a lot of options on the Python side if you were to build your backend in Python. Django is a very rich framework, which does a lot of the database and web controller side of it. I feel it tends to stick you into a very specific model, especially on the data side, which I haven't preferred, but there's Flask, which is a lot more flexible. So if you're looking at Python, both of those are good options. In terms of your database, how you pick that and your options there, if you were going to go with the SQL database, there's MySQL, PostgreSQL are the big open source databases. Of course, there's a lot of other databases and data stores that are SQL based, but most of them are very expensive, but those are great options. On the NoSQL side, if you wanted to go that route, providing a very flexible data structure and query languages, MongoDB is an awesome option. It's very scalable, very flexible data structures, which you can fit into that. Of course, the way that you query that data is a lot different than you would on an SQL side, SQL database. And MongoDB, you can also have indexes into your data, so it can have a lot of features that you're maybe used to or maybe not used to on the SQL side. DynamoDB, if you're in the Amazon Web Services infrastructure, is a great option to get up and running quickly with a NoSQL database. Elasticsearch is awesome for indexing data, documents, providing real-time search to it. And then Redis is another great option too. A lot of great stuff if you want to go the NoSQL route in your backend. In terms of infrastructure-wise, I would definitely recommend going into a serverless model on your backend, which means you write code and you ship it to some service and the system figures out how to actually run it on your hardware. So that means if you've ever tried to run anything on a server, usually you'll have to have some server somewhere where you log in. You need to install your packages. You need to make sure they're running. You need to monitor them. Well, all of these things are handled in a serverless infrastructure. And typically how you would package up your code is as a Docker container. And that's a very portable kind of definition of how to get your code running that then you can deploy out to a number of different service providers in different ways. And I'll give you some really great tools to get up and running and make your code functional much more fast than traditional ways of having to log into servers and install things manually. So there's a number of cloud services which help you with your infrastructure. Amazon Web Services is, I would say, the biggest and the one that I prefer, and we use at VidMob extensively. At VidMob, we have, I don't know how many different types of Amazon Web Services that we're using, but dozens and dozens. Yeah. They have a ton of stuff to help you put your software together, and it's really great. There's Google Cloud and Microsoft Azure, and Heroku's kind of interesting. They have really cool ways of building and deploying out your applications very easily from definitions, and makes that process really easy if you're building web things like that, and they have a lot of tools as well.
So can I ask you why are you using Heroku then?
It's not quite as flexible for especially a lot of the services and data processing that we would want to do in Amazon. Yeah.
Amazon used to have an interesting way of building where you had to buy more disk space to get bandwidth. This was what I was doing with AWS a few years ago. Are they still doing that?
Well, the one thing they do kind of tie to the network allocation that you have is the instance size that you're allocating, where typically on the smaller instances, which are much cheaper, the network bandwidth that they're allocated is kind of lower. So if you do need like a high bandwidth, but not necessarily a high CPU, you're kind of stuck. I don't know if there's really good options. Not so much disk, but instance type.
It used to be disk, is what I'm saying. They used to say if you want more bandwidth, you have to buy more disk, even if you didn't need it. But now they just
it's instance types, yeah.
Okay. And do you know what the billing model is for Heroku?
I don't remember.
Okay.
Yeah. Yes.
You're mentioning all these different languages.
Yeah.
I was just wondering, what do you use for IDE?
IDE. So, no. Well, I typically use IntelliJ, especially for Java, Scala, Groovy. It's got great support for web framework or web-based stuff as well, JavaScript, HTML. Sometimes I dip into like a more bare bones IDE or even Vim, depending on what I'm doing. If I'm working on some Python code, I might just use Vim or something like that. Any questions? So with all of these options, how do you figure out which one to go with, how to choose? I find that this typically boils down to go with what you know or try to learn something new. If you're going with something you know, there's going to be a quick ramp up time. You know how to do things. You know how to start your project. You know how to install the right packages. You know how to code in a certain way that you need to. Then you also know how to solve problems, or you may know how to avoid problems altogether. And one thing that sometimes you forget as a developer is that the technology you use needs to run somewhere in production environment. So you or your team knows how to deploy and manage that. Whereas if you're trying to incorporate new technologies, that can be more of a learning experience, not from just a development side, but a deployment and operation side as well. Some possible cons of going with what you know, and this just might depend on your situation, is that it might not be the best fit for the product or project or solution you're going with. You may be whiz at C++, but if you're trying to build a web app, that's not going to quite work. So you need to try to go with something that fits and works well for that particular situation. It may not be well supported or actively maintained by the community. You may be working on some older technology. You might not be getting updated as frequently, and you may not, or you may get into a situation where development altogether stops on a particular project that you're depending on, and that can make it very difficult to grow your software if what you're basing your technology on is kind of stopped moving forward. And the technology may not be using modern best practices, allowing rapid development, rapid deployment, rapid iteration, rapid testing. So if you were to go with something new, some of the pros would be a large and active community. It would be easy to find solutions. Even if you don't know something offhand, you just, let's say you get an error, you just copy and paste that into Google and it'll just tell you what to do. Hundreds of people have probably ran into it before, and you can find a quick solution there. And then as you grow and as you learn the technology more, you'll have, or you could have much more long-term productivity improvements once you actually get up through that initial learning phase. You could end up moving much quicker than you would with something else. And also new team members that you might bring onto your team might be more likely to know the new technology than if you were to use something that was older or not commonly used today. Some cons would be, of course, the longer ramp-up time. You instead of just knowing what to do when you run into a problem or how to avoid it, you do have to take the time to search for the solution. But then again, once you've done it a few times, you start to pick it up. You could also get into a situation where you're picking something brand new. Maybe the community hasn't reached a threshold yet that would keep it going long term, and you could end up picking something that was a fad and goes out of style. I don't know if you've ever heard of Rust language. That was pretty popular for a while, but I don't really hear a whole lot of it now. So tips for learning something new, if you were to go that route, if possible, try to learn on a toy or a personal project. That could let you kind of work out some kinks in your coding style and work through some initial barriers that you might have. Find some meetup groups for the particular technology that you're looking into. That could not only get you access to interesting talks about different aspects of that technology, but let you meet people that have experience with it or maybe are going through the same learnings that you are. So that can be great as well. Take an online course. There's tons of options out there, Coursera, Udacity, etc., where many of them are free, but some are you do have to pay for, but they can really help you go beyond just like going through a tutorial or some free resources and getting a much deeper knowledge of what you're building. And then, of course, read up on what you're getting into. So before you actually start coding, things not to forget would be incorporating unit testing into your process. It's a lot harder to build in after you've gotten started and can really help you build things more incrementally and make sure that they are working before you move on to the next thing and not, have to build up a bunch of pieces, get them up running, you find half of them are not working and you have to dig through. Internationalization, if you do plan on having multi-language, multicultural audience, that can be, especially on the front end, mostly easier to bake in from the beginning or at least have a plan for it. So you can make language switching much easier rather than having to spend months trying to retrofit something into a new language. Time zone can be important. I've gotten into situations before where I assumed everybody was in my time zone. I don't know why not, but definitely on the server side, keep everything in UTC, and then where you can translate that into local time for the individual user. Logging, of course, can be very important for helping you diagnose things that are going wrong. Once you've gotten your software out in the wild, it's a lot different when you're developing locally and you can see exactly what happens from when somebody out there, you have no clue who they are, where they are, runs into some issues. How do you, debug their situations? If you have logging, that can help you with that. It can also help with a number of other areas, like figuring out how people are using your applications, what areas you need to improve in your applications, what features to focus on and add. Also, I would say it's pretty easy in the beginning to start loading in a bunch of technical debt or unnecessary complexity in your application by taking shortcuts to get things done. But I would say try to limit the shortcuts that you're taking in your code, especially in the beginning. That can be easy to do. And then, of course, planning for growth, trying to make things flexible. So once you get something out into people's hands, you may find what their experience is different than yours, and you may need to shift focus, things like that.
Can you just give an example or two of a shortcut?
Yeah, let me try to think. So one would be maybe hard coding particular situations into your code, like hard coding configurations would be a really bad practice. Hard coding keys to your Amazon resources or other things like that. That's one example. Yeah, configuration management is important. So onto growing your project. In terms of optimizing your code, don't try to over optimize in the beginning. It can be really, you might find a problem interesting to try to solve in the most elegant and performant way, but you may be wasting your time. Sometimes it's a lot easier, a lot better to get something out there that works and does what you need to than trying to make sure it's perfect the first time. And I would say let data drive your optimization process. Focusing on high frequent, long running APIs. Let's say if you're focusing on an API. Here's an example of a data-driven optimization where I took imaginary API that worked with some tasks and users and categories. And from, let's say it's an API log where it's logging the resource and method and how long each API command took to process. I put that into a table with 3 columns. The frequency is just the number of times that particular resource was called, average response time over all of the requests in milliseconds. And that last column's, I think, really important, and that's derived from the frequency and average response time. That's the total response time, it's in seconds, which is a really good measure of the total time that your server is taking to work on that API, which trying to look at the frequency and average response time separately can be hard to try to narrow in on one thing. So having one metric to focus on can be really important. And in this case, the metric I chose was the total response time. If you were to look at the total response times of all of the API calls, we would definitely see that getting a list of API tasks or list of tasks from the API was by far taking up the most time on the server, and that if you were to focus on optimization, that would be a good one to look at first. You can see putting the user is by far the slowest individual command, but when you think about it, that makes sense because that requires updating data in your database, which is a much slower operation than reading data out from it. So that number itself can be misleading, while it still may be something to look at. You want to have a holistic view of what is happening on your servers, and that. So that's what I'd say here. In terms of improving performance, load balancing and adding more servers is definitely one good way to go, especially as your traffic grows. And one challenge with that is knowing how many servers to actually have running at a given time. I would say the bare minimum would be 2, so that if one has an issue, you still have one up and running and servicing requests. Or when you need to deploy new versions of your software, you can bring one down while keeping one up and maintaining your uptime. But when you do want to scale beyond that, keep an eye on CPU utilization of your servers behind it. A good starting point is maybe 80% utilization. If your application's behaving badly, getting a lot of errors, you may want to scale sooner at 70%, say. If your application is working rock solid at 80%, push it up higher. I would say definitely go up to 90%. And the higher you can get it, the better job you've done as a developer getting your software running well. If you can't get it up to 80, you might have some optimization to do on your back end. You may not be handling multiple threads, multiple concurrent database updates very well. So, and then caching is a great strategy for improving performance, taking data that's accessed frequently and maybe not changing as often and putting it into an in-memory cache like Memcache. And that can really speed up performance, especially for your high frequency API requests and those that aren't changing as long as well. Another way of improving performance is separating out your functionality of your applications into different components that you can then again scale more independently, and that through microservices. So let's say you take an upload of a large video file and you need to turn that into different formats. You need to transcode it. You maybe compress it and ship it off to different places. That could be much better done by separating out what backend services actually do the video processing separate from the API that's trying to keep up with the oncoming requests. Onto some major areas of growth. Key would be adding new features. You could grow in how much data you're taking in and how you're using that data, and then you could grow your team, adding people, etc. In terms of features, adding new features will definitely test your software and data design. So try to balance adding new features with understanding how they fit within the overall application. It may be easy to just say, okay, here's this new feature. I know exactly where to put it. I'll just kind of do that thing, but try to think about how it fits in with the overall architecture of your platform, and maybe make it more flexible. So the key would be trying to keep your software flexible to adding new features, maybe changing how the focus of your application, especially as like your business focus may shift, your software may need to shift with it. So keeping your backend flexible and agile is really important. As far as data goes, don't let your data go unused. It can be very valuable for, as we saw, driving how you're optimizing your software, but also how you're learning from how people are using your application and how you can add new features. So find ways to learn from your data. Don't just let it sit unused. And then as you get to do more with data, I would say definitely keep your data processing separate from your core applications, because you'll maybe have a large stream of incoming data. You'll need to translate it, add some other pieces of information, and do all kinds of interesting things with it. And like I've been saying before, definitely keep that processing separate from your API and some other components. As far as your team, you want to be able to adapt to your processes to incorporate new team members, especially if you're starting off with one or a few people. It can be easy to get into a rhythm of just finding something, doing it, getting it done. But as you incorporate more developers into your process, developing a Git branching strategy so that you can work together on things, or you can work separately from things and maintain a stable code base that you can drive your production systems from, are all very important. And then, of course, adopting an agile methodology for how you'd split up your tasks and work on tasks and work with your team members, and Scrum or Kanban are great.
I have my team, my QA team is comprised of caregivers of people with disabilities. So it's so not technical, right?
Okay.
So I can't use Jira, right? And Asana made people run away screaming, which I thought was pretty sweet. I'm sort of looking at Airtable now. Do you have any, what do you recommend for communicating, especially with non-technical people? Because I'm not the only one with non-technical people on the team. Any ideas?
Jira can have some barriers, and that's primarily what I use, especially for non-technical people. Trello is, probably.
That's a good idea.
That's a good
Airtable, I do not recommend Airtable.
You don't?
I would not recommend Airtable. We tried it even with technical people, and it did not work well.
It looks very pretty.
It looks very pretty, but
okay, but Trello. Yeah, because they
Trello's
can just
good.
drag and drop things.
Yes.
I've done, okay.
How do you do screenshots? It's really nice. I'm question about Git branching strategy.
Yeah.
Is there something you could say about like feature branch versus sort of branches by person?
I prefer feature branches because especially when you need to develop a new feature with other people, you may have individual branches per person, but that may be based on a feature branch that incorporates their work together that then you can merge into whatever your main line is for development.
Yeah, it's sort of a granular basically.
Yeah. Yeah, but it is tough to have multiple people working on the same exact branch. That's the thing.
Yeah, yeah. And then do you usually have a primary integrator code reviewer, or is it more flat?
We typically use a primary person per product that has more technical experience with that. Yes.
In the project, at what point do you get involved with user experience?
That would be on the input to features, working with probably designers or somebody who's developing the product level of that. But there can be some iterative process as well. Yeah. So in summary, focus on your MVP to help you guide what you're working on, not just from the features, but how you plan ahead. Again, separate your backend from your front end. Don't bake everything into one repository. Split things out. There's really cool technologies on the server side that help you deploy things and manage things more easily than having to hand code on servers. Make informed decisions on how you're building out your new features and focusing your development efforts, and then plan for growth. Thanks, everyone. I'm going to open this up to questions.
So is this available for people? Your presentation available?
It is not yet. I'm hoping that there will be a way for me to share this through the summit.
Thank you.
Good. Yes.
When you're starting out, how do you handle data? Not having data.
So when you're developing, you might have to make up some data.
Are there any frameworks or applications that generate as fake data?
Do you mean in terms of like unit testing or in terms of just building?
Functional.
Okay.
You need to have a certain volume of data before your application.
That can be hard to do depending on what you're doing. And that can be a key challenge of building your application, especially if you're building a data-driven application.
We actually did build a data generation tool.
Okay.
In order to like even test things, it's like I want to do units of data, just to see a scenario. And on Django, there are some tools. For
Oh, okay.
Yeah, and there's also some good web services out there that can create testing, like scaled, very high volume testing, really stress your system. Feel free to find some I can kind of tell you what some of those we've used in the past for comparing the outcome.
Any other questions? Yeah.
How do you see your SQLite data on the device instead of like on your laptop when you're developing? What tools do you use?
In terms of visualizing it or for debugging or testing?
Yeah, for debugging. Yeah. Did this actually write to the database on the device?
I don't have a good solution to that.
So you have-
Try to get it off the device is kind of my...
You can use, it depends on what you're using, but like if you're using something in Android, for instance, Android platform has a see the local, or you have to do the one, debug it, or see the bump.
But do you mean you're not connected in debug mode? Or
right,
you are?
so I'm using Visual Studio Code, and the simulator, the device runs on here. I can use Navicat or whatever the heck I want to look at the data. And then when I go to test it on my phone, I'm like, how do I see what's actually
Oh, because you can
happening
connect
on-
ADB to your device in real time. So you can kind of see things on a physical device. Is that the problem you're having?
Maybe it is.
Yeah.
Yeah.
Okay, I'll search for that.
Okay.
Thank you.
Can you talk a little more about the microservices concept? Like,
Sure.
Is it a formal definition? Is there a formal definition for it, or is it more so sort of?
It's kind of a industry buzzword, but like my approach to it is trying to separate your functional components into things that can operate independently and loosely coupled from the rest of your application. And if you're in Amazon Web Services, there's things like Lambda functions, Docker and container services, which really help coordinate execution of things in a distributed way.
And are you usually having a preference for your primary backend framework, or not necessarily?
It depends on the
Just
depends on the use case. For an API, Scala or Ruby is great, but then beyond that, you have a lot more flexibility once you can push that out to whether the microservices are communicating directly with each other or they're communicating through SNS queues, things like that.
One of our processing flows for VidMob for managing media. We manage a lot of media, but we've converted a lot of what were originally API-based kind of services to Lambda functions that really now, if they fail, right, it's much easier for us to manage and restart and kind of manage the queues.
So like serializing processor heavy things, you can kind of decouple.
Yes.
Yeah.
Yeah, it can make monitoring things more challenging. So in CloudWatch is okay, but not perfect. So
Because you need folks in more places.
yeah. Again, we are hiring at VidMob. If you are a front-end developer, back-end developer, data scientist, any of these things sound interesting, come find me or our booth downstairs, and we'd be happy to talk to you. Any other questions?
Great.
All right. Thank you, everyone.
That was great.